Welcome to qnawire.
This question it's another question about relativistic kinematics. We have a sigma part that is moving in the x direction. It is moving in the x direction, and it has a kinetic energy K of 180 MeV. And it decays to charged pion and a neutron. We know that the charged pion is in the positive y direction. So this is moving in the positive y direction. It is a two-dimensional question. So in order to solve this question, we want to first write down all the energies we know. Kinetic energy of lambda is 100, sigma, is 180 megavolts. And then we know that the rest mass equivalent energy is 1197 megavolts. And for neutrino, this number is 939.6 MeV. For pion, this number is 139.6 MeV. So let's first find out the total energy of lambda. Total energy of lambda equals the kinetic energy plus the rest mass equivalent energy. So it's this number plus this number. And this energy is 1367 MeV. This energy is conserved in is conserved in this reaction, and we also have conservation of momentum in the x direction. So the in the x direction, momentum of neutron in the x direction, we know the pion in this case is y direction, so it does not contribute to the x direction momentum. So all direction comes from, so neutrino direction momentum squared times c squared is going to equal to the initial momentum. And p squared c squared is equal to the total energy squared minus m squared c squared. Again, if you still remember, this is the equation from the book. This is and c, the momentum and energy relativistically. And we already know what, and then we know what m times c, and this number, to find this out, is equal to 4.633 times 10 to the 5 MeV squared. So this is the equation we have for conservation of momentum. And then we also have conservation of energy, which is a energy of sigma equals the energy of pi. The energy of pion is the rest mass energy, but it also has a momentum component. Similar for neutron, it has its rest mass equivalent energy, and it also has a momentum contribute. This can be rearranged so that we find the mass of neutron is sigma plus mn squared c to the fourth minus m pi squared c to the fourth plus px squared c squared, over 2 times the energy of sigma. If we look at all of the items we have already found of the item, we know what's the energy. These are constants, so more we found out in this. So we can plug all of the known numbers, and the energy turns out to be 1170 MeV. So I think in this case we are looking for the kinetic energy. So the kinetic energy, so let's see, what are we looking for in this question? We are looking for the kinetic energy and the direction of the velocity. In order to find the kinetic energy, all we have to do is we can take the total energy and subtract mass equivalent energy. This is the amount of energy that does not come from the motion but from the mass. And what is left is the amount of energy that all comes from. So this is going to be 230 MeV. So this is our kinetic energy. So I think that is most of this question. It also wants us to know what is the direction of travel for this neutron. That is going to take another page. So a new page. How do we find that? We have to find that using momentum. So momentum of the neutron is given by, again, this relationship. And we can find that is 4.861 times 10 to the 5th MeV. Once we find G, we can find out momentum. But this momentum, it can be in any direction. But if we go back to our previous calculation, we already found out the moment in terms of the x direction. So we can find the momentum in the y direction. And then that will tell us what theta is. So right now, so this is our x momentum, p, that we found in the previous view. That is 100. It is 4.633 times 10 to the 5th equals 4.633 times 10 to the 5th. We find the total, and this 4.861 times 10 to the 5th. And then we can find theta. Theta is equal to arc cosine. Yeah, because this is a cosine angle of square root. This is actually c square of 4.633 over 4.86. This theta is equal to 12.5 degrees. So the direction that this neutron is moving, it is moving 12.5 degrees with respect to the y-axis. So if the pion is moving in this direction, the neutron is going to move in this direction. And it's going to move in the direction with respect to its pion.